I'm going to go over free response question number 4 from the 2021 AP Calculus BC exam. So to start, we're told that f is a continuous function that's defined from -4 to 6, and we're given a graph of the function f. And then we're told that g is the function given by g of x equals the integral from 0 to x of f of t dt. And for the first part of this question, we have to figure out on what open intervals is the graph of g concave up. Well, where is a function concave up? A function is concave up where its second derivative is positive. So we need to take the second derivative here of g of x. So we know that g of x equals the integral from 0 to x of f of t dt. And we'll take our first derivative here. So for g prime of x, well, by the fundamental theorem of calculus, all I have to do is take this and put it right in here when I take the derivative. So g prime of x will be equal to f of x. And then do another derivative, g double prime of x equals f prime of x. So to answer this question, all I need to do is tell where f prime of x is positive. Where is f prime of x positive? Wherever the slope is positive, so here and here. So I'm going to now take the liberty of typing my answer to this question. So I'm going to say g is concave up on, what do we have here? We have -4 to -2 and 2 to 6. This is where g double prime of x, and we'll say, just in case, equals f prime of x is greater than 0. And now we can go on to part B. As soon as it comes up. So here's part B. This time they're going to give us a new function. So this time we have p of x equals g of x times f of x, and we have to find p prime of 3. Well, before we find p prime of 3, let's find p prime of x. So we know that p prime of x, well, I have to differentiate this. I have a product rule here. So for the product rule, I'm going to keep the first function and multiply by the derivative of the second, which will be an f prime of x. And for the second function, well, for the second part of the product rule, I will keep the second function and multiply by the derivative of the second. So I'll have g prime of x. Well, as we know from the last part, by the fundamental theorem of calculus, g prime of x is just f of x. So we know that this equals g of x times f prime of x. So here I have f of x times f of x, which is just f squared of x. Now we have to find p prime of 3. So I have to plug 3 into all these functions right here. So it's going to be g of 3, f prime of 3, plus f squared of 3. And now I just need to compute these values. Well, g of 3 is going to be the integral from 0 to 3 of f of t dt. F prime of 3 is going to be my slope of f at 3. So here's 3, and as we can see, for our slope here, we're going up 4 and over 4. So our slope there is just 1. So we'll multiply by 1. I won't even write it down since we're just multiplying by 1. And then we have plus f squared of 3. Well, f of 3 is down here. It's a -3. So we have -3 squared. All right, now this part is okay. Now I just need to compute this right here. So we have to do the integral from 0 to 3 of f of t dt. So 0 to 3, I need the area. I need this area right here. Well, guess what? Base here is 1, height here is 4. Base here is 1, height here is 4. One of those triangles is above the x-axis, the other is below the x-axis, but they have the same area, so they cancel each other out. So all I need is this area right here from 2 to 3. Well, I have 3 of these squares plus another half. So that area right there is going to be 3.5, which is the same as 7 halves. So I'm going to say this is 7 halves plus a negative 3 squared. I suppose if you really didn't want to figure out what 3.5 is, you could have written 3 plus a half. I don't know if they accept mixed numbers on the test, but this should be an okay answer right here. And now we can move on to part C. So for part C, we have to find the limit as x goes to 2 of this right here. Well, as we'll see, g of 2 is the integral from 0 to 2 of f of t dt, which, as we showed just previously, is equal to 0. And when you plug in 2 right here, 2 squared minus 2 times 2 is also 0. So we have a 0 over 0 situation. Now we have to be careful with how we write this, because if you just put down 0 over 0, L'Hopital's rule, you will lose a point. So we have to specify that because the limit as x goes to 2 of g of x equals 0, and the limit as x goes to 2 of x squared minus 2x equals 0, L'Hopital's rule applies. So I'll write it out. L'Hopital's rule applies. So I can say that this equals the limit as x goes to 2. So to use L'Hopital's rule, I can just differentiate the top. So I have g prime of x, and differentiate the bottom. Differentiating the bottom, I get 2x minus 2. Well, g prime of x is the same as f of x, so we'll say that this equals the limit as x goes to 2 of f, well, not f prime, just f of x over 2x minus 2. And since we no longer have a 0 over 0 situation, we can just plug in our numbers here. So f of 2, when I plug in 2, f of 2 is going to be down here at negative 4. And when I plug in 2 on the bottom, I'm going to have 2 times 2 minus 2. And this is our answer for part C. And now we can move on to part D. So for part D, we have to calculate the average rate of change of g on the interval from negative 4 to 2. So let's start by doing that. So we know that the average rate of change of g is going to be g of negative, well, we're going to start with g of 2, and then minus g of negative 4 over 2 minus negative 4. All right, this is just going to take a little work. I have 2 minus negative 4 on the bottom. That's like a factor of 1/6, which I'll put over here. And then I have to do g of 2 minus g of negative 4. Well, g of 2 we've shown many times is just 0, right? Integral from 0 to 2 of f of t dt is 0. So I really just have to do minus g of negative 4, which is going to be the integral from 0 to negative 4 of f of t dt. Well, this is kind of backwards to go from 0 to negative 4. So I'll just use this negative sign right here to switch the order of the limits. So I'll say that this equals 1/6, and now we have a positive integral going from negative 4 to 0 of f of t dt. And now we can just compute this integral. So we have the 1/6, and then we have to do the integral from negative 4 to 0 of f of t dt. So we're looking for all of this area in here. So I'm going to divide this up. I'm going to deal with, it's kind of difficult to, there we go. I'm going to deal with these areas separately because now I've just divided this region into a rectangle and 2 triangles, and I know how to find the area of all of those. So for this first triangle here, the base is 2, the height is 6, so half of 2 times 6 is 6. And then for my rectangle here, height is 4, and the length is 2, so this area is going to be 8. And for my triangle up here, the height and the base are both 2, so half of 2 times 2 is 2. And so I just have to add all these up to get my area, so this is going to be 6 plus 8 plus 2. So that was the first part of the question. And now we have to do the thinking part. Does the mean value theorem guarantee a value of C between a negative 4 and 2, for which G prime of C is equal to this average rate of change? And we have to justify that. So I'm again going to pull up the notepad and type this. And the answer here is going to be yes, because we know that G prime of x, which is the same as f of x, so I'll put that in here, is continuous on the interval from negative 4 to 2. And because the first derivative of g is continuous, that implies that g is differentiable on negative 4 to 2. And therefore, the mean, well, they like it capitalized, I guess, the mean value theorem applies. And I think this answer would be okay.